Hello, my name is Matthew Castronuovo, and this is my Georgia Tech Physics 2 Lab 1. So a quick intro to my lab. The goals of the lab were to understand how charge is transferred between strips of tape, and implicit in that is how to create charged strips of tape. Attempt to computational model the previously mentioned interaction in GlowScript and to solve for the charge of the tape. And so to do this, you need to have an understanding of the underlying key concepts such as Coulomb's law, transfer of charge, and electric charge. Coulomb's law, as shown in the equation in the top right, can be modeled as F equals K Q1 Q2 over R squared. Now, notice that this is a scalar, not a vector, so this is the magnitude of the electric charge, where K is equal to 9 times 10 to the ninth. Q1 and Q2 are the respective charges of the two particles involved, and R squared is the scalar distance between the two particles. And then, quick preview of the results. We computed the charge of the tape to be 4.57 times 10 to the negative 7th coulombs. So the initial conditions and the experiment. I made the charged U tape and put it under another charged U tape that I made, and measured the charged tape to be zero point 0.2 meters, and then using the fact that we know 1 gram per meter, uh, made the knew that the tape's weight would be zero point 0.2 grams. And we also observed the height between the two tapes once the top tape appeared to defy gravity to be 0.031 meters. And so these are some excerpts from my computational model. These are the three functions that I created. The first one to find the charge of the electric field using Coulomb's law, where we calculated R hat, and new Q, so that way we were able to find the vector form of the electric field. The second one is physics one concepts, just calculating the vector gravity force. And then function three was going to put that together and find the force of the first charge tape on the second charge tape, just using Coulomb's law. Now, the results of the experiment, we computed the magnitude of the gravitational force to be 1.96 newtons, and we knew that that must be the same as the magnitude of the electrical force. And so, using that knowledge, we calculated the fact that the charge of the tapes were 4.57 times 10 to the negative 7th coulombs. Notice that it is actually negative 4.57 because it's a negatively charged tape. And so some possible errors and discrepancies. Touching the tape causes it to lose its charge. We might have accidentally touched the tape. The humidity in the room is variable. If there was a higher humidity, it would have taken a smaller height for the tape to move, thus having a smaller apparent electrical charge for the tape. And the weight was just an estimate. It wasn't actually measured to be 0.2 grams. Furthermore, the computational model is a simplification that treats the tape as a point charge when in fact we know it's not. So now some analysis. Why is it important to not touch the charged tapes? Well, that's because um, touching the tapes would actually cause the tapes to effectively lose their charge because the excess electrons that are built up in the tape would flow into the surface that it comes into contact with. And what if the electrons now had a positive charge? Would we see the same results? No, but yes. It would not lead to a numeric change in the results. All the numbers would be the same. It would just be a nomenclature change where now we consider the charge to be positive instead of negative, and it would just be a sign flip. It would not actually lead to